let's get started. I hear the rumor has it we stopped on lecture 12. I guess I could go take a look at the video from last time. But let's see. We're going to cover, I really want to get to the lecture number 17 today, which is on cloud computing. And this is of the MIT series, Management of Information Technology. That's what MIT stands for, not like the university MIT. So it's not to confuse you with that. I'm going to start in with this one here, and then we'll go back and take a look at that other one at the end of the lecture, and we'll take a look to see. Otherwise, if no one can remember where we even stopped, I'm going to assume it wasn't that memorable, or wasn't really. I think I was talking about, oh, actually, you know what? I think I do know where I stopped. I think it was like around new technologies, biochip devices, Bluetooth. I think I was talking about Web 2.0 and 3.0. I know it was like a week ago. This is around slide 42. Let me finish this one then, actually, because now I know where I stopped. It was around here-ish. Yeah?
We were discussing about audio recording.
Audio recording?
Yeah, ERP or something. ERP technology.
Oh, so it was back further. Virtual reality. Oh, maybe speech recognition? Yeah, automatic speech recognition. I think we're around here. Okay, good. So we'll continue this lecture then. And I do want to get in. We still have one more class meeting, so I'll start cloud computing if I don't make it that far. And we'll definitely get to that topic. But this lecture that we were talking about was on 2.0 Web 3.0 and on new technologies and up-and-coming new things to consider in terms of engineering management, things to bring into the business, and things of noteworthiness in terms of technology. So I think I stopped around here. So capturing spoken words, distinguishing word groupings from sentences, and doing audio and as well as text recognition, which is an upcoming thing and becoming more of a reality these days. And Siri is an example of that. But that's not really text or audio recognition. That is more along the lines of an assistant who's providing information for you in an audio kind of format versus a text, which is what you get from a web browser if you think about it. A text web browser, Google is sort of like Siri. You just type something in there and the web browser, the web engine brings back, or the search engine, excuse me, brings back the results for you, which is kind of like a text version of the Siri concept to begin with. So a three-step process that gets into the automatic speech recognition, which is what ASR stands for. The feature analysis, the pattern classification, and the language processing that goes along with it. And so it's a theory broken down into a couple of different steps to create audio as well as text as well as other formats of the recognition process of human-computer interfaces. We also have virtual reality that's playing a huge role these days. In fact, that's what Web 3.0 is pretty much about. There's no separation anymore between reality and the computer. I mean, it's pretty much integrated with Web 3.0. We don't know if we're on the computer or if it's real. I'm not talking about like a hologram or something like that. I'm talking about information and content, services, and features of our daily lives. So virtual reality is a three-dimensional computer simulation. Looking at participating and using three unique devices these days in the current media: the gloves, the headsets, walkers, stuff like that. Walker? Huh. Stuff like that. Anyway, so I always think of, when I think of virtual reality, I always think of like for handicapped or for human aid, like to give you a hand when you don't have a hand, or to give you an extra hand so you have 3 hands instead of 2 hands. And it's augmented reality. Augmented reality is sort of like virtual reality, except for it brings in virtual concepts into real reality. So augmented reality is used a lot in the movie industry these days, actually, to make these sets so that you're having a scene occur at a place, but the place is virtual. It doesn't really exist. It's augmented. So in terms of the devices here, the glove, actually you could add the goggles now. Google goggles are part of virtual reality. Capturing moments for glove, handsets, head-mounted displays for I/O. That would be your goggle concept. And the walker captures movement of the feet as you're walking or running. Virtual reality applications, Matsushita, if I said that right, probably not. Designing your own kitchen. So, Volvo demonstrating car safety features, Motorola. There's plenty of different ones actually, because virtual reality has been around for a while. This lecture is about 3 years old, so you can basically add a lot more to that list actually right now. Okay, automatic virtual environment is a platform special for 3D reality. Rooms can display people and objects in them, or other caves. Holographic devices, things of that nature. You see this a lot in gaming, actually. So you have the web with people. So here's the cave automatic virtual environment kind of concept. So. And then visit friends and family without actually going on an airplane. Just bring them virtually, which is actually kind of a reality these days with the telephones with the cameras next to them, and like iChat or like Skype for that matter, where you can actually see the person, talk to the person. That's not virtual reality. Virtual reality would be a hologram of that person perhaps, who is not really there, not really talking, but they are talking. So that kind of reduces down the personal nature of the communication for the most part, but could create an interesting environment. Customer service, more applicable for non-personal things like customer service. So the agent will appear next to you, making a call or something. So possibilities are limitless. So. Haptic interfaces, technology to add a sense of touch to an environment that previously had only a visual or textual elements to it. So now we're going to add touch to it as well. Being able to touch a keyboard that's not there, or a machine that's not there. So stationary jet ski from an arcade game. So the jet ski moves and rocks. I don't know if you guys have been on like the motorcycles or the cars or the jet skis or the snowboard, and the whole thing just moves. That's this haptic interface where you're touching it. You're standing on a snowboard or something, and it's moving and giving you that kind of sense of reality. Actually, they film these people playing the game sometimes as well, and it looks like they really are on the device. They really are doing it live. So certainly not the equivalent to going on vacation and going skiing, but it's closer. Joystick and game controllers. The Wii actually revolutionized it. And now you can talk about Kinects, and actually the Wii was like one of the first to do it. And then we have other devices out there where it has hand and eye, hand motion detectors, so you can play the sport and do the thing in your living room. Biometrics, another form of technology used a lot these days as well, used for characteristics of fingerprints, iris, voice, sound, and even breath to provide identification, actually. That's a narrow definition, actually, in terms of the concept. It can also be custom fitted for clothes using biometric. So, actually, there's a lot of bio clothing these days, which is actually kind of interesting, and a computerized clothing these days, more than just watches, actually. Custom clothes and biometrics, yes. There are, shirts and pants and shoes and things that have computers in them that count, like your shoes can count how many steps. These are real products on the market, by the way. Can count how many steps you've walked or something. I can keep track of your blood pressure, actually, can keep track of certain things about your biological state, yada yada. Also, so can your shirt, can tell whether or not you're cold or hot, and warm you up or cool you down, depending upon what the condition might be. A lot of athletes have experimented with these for comfort while exercising or comfort while performing a particular sport. I always remember going back to the snowboarding and the skiing, those little things you crack and you put in your gloves and stuff, and those that warm up your hands so your fingers don't freeze, and you put them in your boots. You shake them, you crack them, and they're like heating devices. Well, now they have shoes and gloves that just heat on their own. So I'm like, man, I need to invest in some new equipment. Little battery-operated shoes and hands that just warm up for you without having to actually kind of stick something in there and worry about it. In fact, automatically drying clothing would be good for that sport as well. So you walk, you leave the slope and your clothes are automatically drying off for you. That's nice. And remove all the excess snow from your shoes and stuff. And the dirt, that'd be good too. So, Biometric is also used a lot in security. Best ways known for password. Well, best security is 3-step password protected, some card and some biometric. A combination, because it's more than just the biometric, because people can fake biometric actually. I'm sure you've seen the movies where you have the gloves, you stick it on, it has somebody else's fingerprints on it. They even have lenses you stick in your eye. You have different IRA signals. So you can duplicate somebody's irises, you can duplicate their fingerprints, you can duplicate their facial, you just get a mask, you've got the facial stuff done. So that with a password or maybe some sort of RSA key authentication or something, some automatically generated password key component or something also would be good for that. Then we're talking a higher level of security. Today's ATMs, for example, use only the first two. They don't use biometric. So one reason why identity theft is so high is it's easy. It's easy to steal someone's identity, actually. All you need is a couple pieces of information about them. In fact, there was a couple of different identity stories recently, actually. Now, identity thieves are buying houses. They used to get credit cards, now they're buying houses, which is actually kind of interesting. And then they pay the mortgage on the house, and you can get credit cards and stuff in somebody else's name and use it. And it's just like a feeding off to somebody else's credit, I guess. But, if you can't afford a house, just steal someone's identity, buy a house. Who owns the house? Actually, the funny thing is the bank owns it because the person who stole the identity committed a crime to buy it. So in the failure of there being a real owner, the bank gets defaulted by the person who actually owns the house. In reality, banks own everybody's house anyway, so it doesn't really matter, but unless you pay it off, over 30 years or so. But long story short, it's an interesting concept to steal someone's identity and then use their credit to buy a house. It's interesting. I never really thought anyone would actually do that. But apparently that's pretty popular right now. Cars, houses, and stuff, where they make the car loan. They actually pay, they just can't afford the loan or they can't get the loan on their own, so they steal somebody else's credit so that they can do it. They used to call them co-signers. If you couldn't afford something, you couldn't buy something, you could just have someone sign for you. So you use somebody else's credit as well. But that person's generally aware of it. So you might be co-signing or, your credit might be being used for purposes you might not necessarily be aware of without them actually taking your money. And anything, they're benefiting you. Hopefully they're benefiting you by giving you a better credit score because now you own a home and giving you better advantages. So TPS captures events. This is TPS stands for transaction processing. So integrated biometrics with transaction processing, giving you and capturing events for transactions using biometric processing. Helps you with weight loss, pregnancy, use of drugs, alcohol level, vitamin deficiencies, all sorts of different purposes for transaction processing. So the transaction processing system is the who, what, where, when, what amount. Biometric processing system is the alcohol, the drugs, the hair loss, and then the business information or business intelligence system is the transaction processing, making that happen, making that possible. So integrating biometrics with transaction processing. So they do this for criminals all the time. They call it drug testing, the person's on probation, they'll drug test the person, and then the court will decide whether or not the person should remain on probation or whether they should get special handling or treatment or something. Students actually don't get any biometric testing, but they probably should, actually. In fact, before you took a final exam, because final exams are coming up, so we could talk about finals. If they had a fingerprint analysis, well, now we check IDs, but how many people have the same ID at this school? Yeah, no, don't look surprised. We actually, at one point, we had professional test takers. That's been wiped out now that we have pictures on the IDs. But yeah, no, a couple people would have you could buy them and you buy the service. Someone comes in, takes the test for you. They're professional test takers. Actually, this happens in the real world. It's just not ITU. It's everywhere, actually. There's this thing called a professional test taker. You have to pass a major exam. So you pay for it. the guy shows up, got an ID, looks like you, kind of, sort of, or it's a girl, looks like the girl, kind of, sort of, goes and takes the test, passes the test, hopefully. I guess if they don't pass, do you still have to pay? That's a good question. And then you get credit for taking the test. So, and we had this at ITU, actually, not documented, but there was suspicion of this a couple summers ago, like a long, long, long time ago. And way before we got accreditation, by the way. So we're talking like maybe 5 years ago or so. And then people went, what in the world is going on? So now you know why they keep checking IDs. They'll check IDs for attendance. They'll check IDs for exams. Everywhere you go in this place, you have your ID checked. And your ID has to be a picture ID or a government-issued ID. Because it's hard to put somebody else's picture and look, you know, have 5 people look like the same person. So not a problem anymore. So I would say that that's an ethical use of biometric, and the biometric is your picture. Now, if we had fingerprint, that would be even better. You know, just put your fingerprint on the exam as well, and then scan your fingerprint. There's some IDs that do that, actually. So you have a little spot, you put your fingerprint down on it, and then it goes through a computer, and it lines you up to authenticate that that's really you. Now they even have it so you just put it up next to a screen. There's no ink involved either, so it's pretty good. So we haven't gotten there yet for our exam taking, but that's kind of, I want to say, an extreme. A lot of people don't think it's ethical. You know, can banks use ATMs to determine if you've been drinking, or, you know, you're going to use biometrics everywhere. People are going to discover things about people. And then the ethical reason comes into place. It's like, are you using that for something that's not related to the purpose of why you provided that information? And that's where the ethical part comes in. So how businesses of the future use biometric information? That's a good question, actually. A lot of people have that problem with health insurance, health stuff. It's like, you know, they don't want to put it online, because if they put it online, then someone's going to use that information. It might not be for a positive thing, it might be for a negative against them or something. Other biometric devices, the biochip performs physiological functions when inserted into the body. It's like the artificial pancreas or the different biocomponents that people use to augment the natural biology to make things work, or to improve the process of something. Implant chips implanted for the body that stores information about you, where you are. Actually, they're putting these in kids now too. They're putting them in the scalp. So for the longest time, dogs. In fact, dogs right now, it's got common practice. You have a dog in the U.S., you put a biochip in them. That way, you lose your dog, you know where the dog is. It's like the car. It's like the LoJack on the car. You can find your dog too. It's down the neighborhood. Just go on the computer and look your dog up. Well, they're doing it in kids now too, because the chips are really small. It's just a small little cut. You stick it underneath the skin and you seal the skin back up, or you just put a Band-Aid on it, it heals on its own. You just have to attach it. So they're attaching it on the scalp, under the hair, or behind the ear, which is also a good spot for us. So you might check your ears to see if you got a chip back there. Maybe your parents put it in when you were a baby, you know. Walking around with this chip in you. Well, because you know how many child abductions there are these days. And here's the season for it. More happen around the holiday season than any other time of the year. Then, you know, you're looking at, you know, is the difference between losing your child and being able to save your child. There's a chip planted in there. Definitely, same problem we had with animals, with pets. Just transformed a little bit, evolved a little bit more. So, anyway, long story short, that's a very controversial topic area, those implants. But GPS tracking, Family 4 in Florida already have them, according to this lecture, about 3 years ago. Now I'd say about 30% of children out there actually have the implanted chips. They wanted originally, you know, they've had them for years with bracelets. You hide it in the shoe. And what is the first thing an abductor is going to do? Take all the clothes off the kid. And that's going to defeat the purpose. So you're going to have to put it on the body somewhere. So they actually have it now where they can do sort of a tattoo with it. So it's tattooed in. It's like a form of a magnetic thing that's put in. And it's just sensed by a tower. So, well, it's by GPS. So Facial recognition software, providing identification for evaluating facial characteristics. I don't know, facial recognition doesn't always work, however. There's a few things people can do to disguise themselves for the most part. But I like the chip technology. So, I don't know, I've yet to put a chip into somebody, but it might be an interesting concept. If they had a chip, then they wouldn't be, there's not gonna, if anything, it's like those fake video cameras. All you gotta do, if you're worried about being ripped off, your home being invaded, just put a fake camera up there. They're so real looking now. Actually, just put a real camera up there for that matter. Just having the camera, just like having a chip in a child, would definitely deter people from taking it. So, that's what they do with the dogs, actually. In fact, they put a little collar on the dogs and say, the dog has a chip inside of it. Oh, you're not going to steal that dog because you're going to be arrested. Leave the dog alone. So, it was mainstream. In fact, they started fingerprinting children recently, like about 6 years ago, maybe 10 years ago by now, actually. Fingerprinting has been around for a while. They started registering and fingerprinting children for that reason. Because if that the child is fingerprinted, you're probably not going to abduct them or something. Hopefully not. So, anyway, Bluetooth, short-range communications. Actually, this is very current. As of last week or the week before, the Bluetooth problems with cars. You guys use those keys that automatically open your doors and you stick them in your pocket? Most of them are Bluetooth, or they're wireless. You can open up your car without actually taking your key out of the pocket as long as you have the key with you. Well, when there's a device, there's a way of duplicating the device. And there's universal devices now. So cars are getting broken into quite easily. You just walk by. In fact, cops it's actually pretty easy for this. It was on YouTube and it was on the news, actually Channel 2 News, about last Friday, I think. Not the Friday after Thanksgiving, but the Friday before. Apparently, it's pretty wild in San Jose, where you just walk by. The thief just has to walk by. If he hears the doors unlock, he knows it works. So the doors get unlocked, and then he pretends like, well, it's his car. Goes in, takes and clears everything out. Any money, anything left in there. Then keeps walking. Only works on those cars that have the keyless entry, but it has not the remote control one, but the one that is with the Bluetooth device, or with the key that you don't even have to start the car with. You just press a button. If your car starts with a button and not a key, be careful, especially in San Jose, because it's kind of gotten a little wild right now. Last couple of weeks, San Jose Police Department has been reporting multiple incidences of this. And what they'll do is they'll go through the parking garages, because there's nobody in the parking garage. So you go to a concert or something, you park your car there, use the regular key, turn that off, and then otherwise when you get back, there's not going to be anything in your car. Well, or don't put any valuables in your car. So, but if they can open up your doors, they can start your car and take your car as well. It's the same concept. So that you just press the button, and your car starts, and then they just drive away with your car. So anyway, pretty bad. Anyway, so long story short, be careful with that type of technology. There's only maybe about 20% of the cars out there that fall into that category. You have to buy a brand new car in order for that to happen, actually, because the older cars don't have that technology. And even the newer cars are putting in devices for extra security right now to protect that. Just go back to your car dealership, tell them, if you have a concern. And usually they'll change the code or they'll encrypt it. So it adds another piece of security to it. But yeah, Bluetooth is interesting in terms of security. Wi-Fi also, long-range communications, RFIDs, next generation cell phone technology will hopefully be over Wi-Fi, voice over IP, if you haven't figured it out already. Next generation cell phones are hard disk, upwards of 2 gigabytes now. Processors, well, actually 16 gigabytes, 8 gigabytes. 2 is pretty small right now. This lecture is about 3 years old. So, actually every year things double. So next year it'll be 32 gigs or 64 gigs. It just keeps going up. Music enhancements, video support, iPhones. We got iPhones out there. Mobile sods, short-minute video clips for TV shows designed for viewing on small devices. Actually, we don't even need that anymore. We have the full 3 or 4 gig DVD accessible via the cell phone and downloadable within minutes or so to watch. So you don't have to worry about the small files anymore. Now you have the big ones. There is a downside to it. Cell phones equal next generation playground for hackers and virus attacks. Yep. No good antivirus software for cell phones right now. Actually, I'm waiting for it. BlackBerry had a virus a few years ago. It was like a single incident. Then they since got rid of it. I'm waiting for the viruses to end up on the Android phones or the iOS phones. No one's invented a virus yet. But they can't attack computers anymore, so now what are they going to work with? Phones, tablets. I don't download ringtones from websites. You can be downloading a virus. Most of the time you do, actually. But your virus protection will pick it up. So RFIDs, radio frequency identification, uses a chip and a tag or a label to store the information transmitted from, written to, exposes to correct frequency of the radio waves. Common RFID is passive. They call it passive technology. There's no battery power either, which is actually kind of interesting for Bluetooth. The reason why Bluetooth is popular is because it's very low battery consumption. There's still a battery need, but it's very small compared to Wi-Fi or compared to other technologies. RFID doesn't have any, actually. No battery consumption, which is actually kind of interesting. Antenna absorbs the radio waves and stores as energy. So it's stored in a chip, jolted for life. So you could put RFID tags, and here's a good tag here, on products in stores. Ever wonder why, like 5-6 years later, you go back to, those little tags you see on the book. They used to put them in books all the time. And then people would have a library book from like 5-6 years ago, walk through a department store with it or something, and then the thing goes off. Sensor thing goes off. Because the thing is still transmitting a signal. Because it's going to last forever. And then they realized, well, that's good, but do we need it on all of our products? And if you could put it in a sticker, then we could track who's where and what product is where. And then all of a sudden, this is like the #1 thing you see in theft devices for stores. And if it's cheap enough and there's no battery, there's no real expense, and it's just wiring, you just throw it away. So they're very disposable. So here's a reader, computer system with account information. Here's a little tag on the left-hand side over here. Applications for it. Speed passes. Actually, we have it on our toll bridges. Uses an RFID technology. You go under the toll thing, and it clicks your thing that you put. You have to put it on the window. It has to be visible. Well, because it has to be able to be read through the glass. So, long story short, it'll collect and pay your toll as you go through. Toll booths. It's been used for years for that. Actually, yeah, it's pretty good now. So instead of swiping cards. They actually had this, couple of retail stores actually did this for credit cards because they're starting to put the little chips on the credit cards. You just take your card out and you swipe it, or you don't swipe it, you just wave it, and it picks up your information for you instead of having to swipe it. People don't like that because the card could be in your pocket. It's just like the problems with those cars, and anyone could just charge anything they want on your card. So the security part of it's a problem. A library book tracking, the Vacation does it. The Vatican does it, yeah, for library book tracking, actually. Livestock tracking, supply chain management, supply train. Automobile factory make, little tags they put on sub-assemblies. So you can, at any one moment in time, look at a screen in a manufacturing plant for an assembly line and see where your bottleneck is. Because all your parts and pieces have tracking RFIDs on them. So you can tell if one station is having a problem or if a piece of equipment's not working right. It's slowing down the flow of the manufacturer that's going on. So, passports coming to the U.S. It still hasn't made it to the U.S. We don't have any RFIDs on our passports yet. Because somebody thought it was a security issue. Because then the government or then the people would know where people were. If you're traveling and you have a passport on you, you know where you are. So if you're sitting at a restaurant, then you're not at your hotel room. Or if you're sitting in a restaurant, they know you're at a restaurant. So long story short, it's an invasion of privacy for the most part, so which is why a lot of people don't like it. For the future, each and every product will have an RFID on it. theoretically. We have product codes now. We have barcodes on our products. So they're saying someday in the future we'll have RFIDs instead of barcodes, because then you can read it electronically. But barcodes can be scanned electronically. So everyone has those scanner guns now at all the retail stores. So uniquely identifies each product, expiration dates, places traveled, etc. It would be nice to know where your products came from, especially your vegetables or your fruits or something. But who's going to scan a fruit before they eat it? Or it just seems like a waste of technology when we think about it. So we have pure technologies, and many have broad applications to them, numerous areas. As example, nanotechnology, multi-state CPUs, holographic storage devices, all sorts of different pure technologies in the coming weeks or months or years from now. None of this stuff is a reality, by the way. They've been saying this for about 3 years or so, this making of this lecture. Nanotechnology. We almost have nano hard drives right now, actually. Discipline seeks to control matter of an atomic or subatomic levels of purpose of building devices with small scale. So instead of using solid state drive, they have nano-like solid state drives ish for data storage. Shows a very high probability of future success in that area. Because it's not heat producing, well, neither is a solid state drive either, though. And there's no moving parts, and the storage capacity is very, very large. So it definitely could be used for hard drives in the future. There's a lot of experimentation with it right now. There may even be a company that's got one out right now as well, but it's not mainstream. Current approach: start big, squeeze, press, slice, dice, make everything smaller. Nanotechnology approach with the smallest element being the atom and building it up. So, multi-state CPUs. Right now we have the binary. We still have binary CPUs, by the way, zeros and ones. In a multi-state, we can just have more than 2 transactions. We can have 0, 1, 3, 4, 5. We actually sort of see this from a software perspective. We have certain processes and things that go on in an operating system when the computer's turned off. So it's off, but it's not off. So it's not a 0. It's a -1, or it's somewhere in between 0 and 1. 1 would be a completely turned on computer. So we have things like backups and network activity and stuff occurring in between states, which is actually kind of interesting. That's how we get better battery consumption for the most part as well. We just turn certain things off, and the smart multi-state system could figure out if the user is actually using the device, or if the device is supposed to be sleeping or something, turned off. So make computers smaller, very fast, actually. So holographic storage devices here, storing information on a storage medium that is composed of 3D crystal objects, sides and faces on them, instead of flat objects. Provide tremendous storage in a small space environment, especially if these are micro-sized. And you stick them on the surface instead of a flat disk surface. You have a holographic type of environment. You have more sides, more surface area. Important considerations: necessity of technology, choosing the great digital divide. Well, actually knowing what to digitize, what not to digitize, what technologies to invest in, which direction to go, what's going to suit society, privacy, convenience, ethics, stuff like that. The necessity of technology is actually kind of interesting. In fact, this major, engineering management, never really existed before technology. And then you have technology, and then all of a sudden it's like, well, engineering. Why in the world would anyone have to manage engineering? About 20 years ago, people wouldn't even think of this concept of engineering management. Like, what in the world will what engineering's not mainstream, was not mainstream back then. It's now it's like more mainstream than business if you think about it. And there's more jobs in it than there are traditional business jobs. So, which is kind of interesting. Actually, it creates this whole brand new need for people skilled in the area, and then they go, well, what is the area? Well, technology. But what's technology? Think about it. It keeps changing on us. There's no really good definition for it either. Engineering is building things and creating applications for technology and using technology, but engineering may not necessarily even be associated with high tech or with computer technology, as you can possibly imagine if you think back to the railroad industry. That's engineering, railroad engineering. In fact, transportation engineering is still a viable career option these days. engineering routes for buses and for trains. Scheduling planes and stuff is engineering. Think about it. So it's everywhere. It's inescapable, and it's up to you how it gets used and what percentage of your life is being used with technology and engineering. So technology challenged countries and cultures must take technology to those places to implement things, which is actually kind of funny. If you go into areas of Asia, or actually go to Japan, that's an interesting concept. They were like one of the last last countries to get wireless technology, but they have better service than in the U.S. because they waited. So it's like the late adopters are getting the greatest technologies. Earlier adopters are still using slow stuff, like wired landlines and stuff, or like 2G, 1G systems, because they put the system in back when the technology wasn't as good. Technology got better. What are they going to do? Replace their entire system? No. Instead, they're just going to continue using it till it breaks or something, or till they get their investment back. But people just buying it now are going to get the best of everything. So, because that's what's available now. And it's usually cheaper than it was back when the old technology was for sale, which is kind of ironic when you think about it. But yeah, some third world countries have really good internet access, and some of it's free. When you think about it, going in the U.S., we have really bad internet access everywhere compared to elsewhere, but we've had it longer. That's the problem. So technology is a betterment of society. So business people taking money, that's okay. Technology can also be used when no money is to be made, and that's great. Well, medical applications of IT will never make any money, usually. So, but it helps people. So, just like anything else in society or in the world, you can use it for the good of the better, or good, or whatever, or for evil, or for whatever purpose, for making money, whatever purpose it has to be there. Exchanging privacy for convenience. That's what people are pretty much doing now, in terms of their expectation of privacy going away, because it's more convenient not to worry about your privacy. Just put everything online, just get everything out there, and it's more convenient. So don't give up too much privacy, but people have given up a lot, actually, in the last several years. Ethics, and more ethics. You take an entire class in business ethics and still not cover everything. They're essential, important part of doing business. Can't cooperate without them, but use technology wisely, because technology has a tendency, and engineering actually has a tendency to create ethical issues for society in general. So that was the end of lecture number 12, and as promised, we're going to get into number 17. So let me go start this one here. Excuse me, this is not this is MIT lecture 17. So we have this week, and we have next week. And then we have the final exam. And then we're done with this course. So this is the second to the last lecture, which means your assignments are going to be due very soon. If you have not started turning them in, turn them in now. Do not wait until the very last day of class. If you do that, you're not going to get them in. The EMS will go down, and there's no extension on the deadline. The deadline is the deadline. Does anyone know when the deadline is? The 16th. Excellent. And I think the 16th is the day of our final, isn't it? Monday the 16th? So that's like 2 weeks away from today. So don't be foolish and wait until the 15th to upload your stuff. In fact, if you haven't done it already, you're going to notice problems, because other classes have other students who are submitting assignments, and the EMS always starts running a little bit buggy right now because of that. It's increased usage, essentially. So long story short, when you get done registering, turn in your assignments. So register first, do assignments second. So if you haven't registered yet, go ahead and register. Otherwise, there won't be any classes for you to register for. Okay, so this is our last lecture, which is the reason why I'm bringing this up. I'm going to start it today, finish it next week. And then next week I'll go over a little bit on the final, but we don't really have very much on the final. I've already done it already. The final, just to reiterate the point, it's going to be about 25 questions. You pick which ones you want to answer. You'll answer 5 of them. And the questions will be short answer, sort of essay format. So no multiple choice, no fill in the blank, nothing like that. We're going to give you some paper, and you bring a pen, and you write the answers on a piece of paper. No computers, no internet. You'll actually have to write yourself, and it might be the first experience in your entire life where you've actually had to come up with your own ideas and your own thoughts about something without consulting the internet. So it's not cut and paste exercise, it's a writing exercise. You'll have questions, and one of your questions will be on cloud computing, actually. That's why I'm covering this topic. And there'll be a question on new technology, Web 2.0 and 3.0. There'll be a question on Porter's 5 forces model. There'll be a question on top line and bottom line. There'll be a question on all these topics I've covered throughout the course. So next week, I'll bring the exam in and I'll give you the topic areas. But for the most part, what you want to do in the next week to prepare for it, get those assignments done. All the topics are in the assignments. Get your assignments done. And then when you're finished all your assignments, start looking at the work. You know, start looking at, well, what lectures did she go over? And what lectures did I need to use for the assignments? And there's your topic area. I'm just going to regurgitate that to you next week as well. But you'll have all that. You already have all that information. So don't ask me what's on the exam. Because if you've been doing your homework and you have it all, if you've done your homework yourself and you've turned it all in, you know what's on the exam. It's all in those topic areas. So, and they're open questions. So if you don't, for example, cloud computing, and if you don't know what cloud computing is, or you don't know the textbook answer, no problem. You can come up with your own answer. And so here's some suggested answers to the question, getting into this topic, where, you know.
Hi, do you mind if I make an announcement really quick?
Sure.
It's 25 rounds. It's really quick.
Do you know if Joel's going to be taking attendance soon?
He should be coming.
All right, so I was about to give you a definition of cloud computing. And most people started writing some stuff down. It's like, yes, you'll be asked a question on cloud computing. And the question will probably be more like, you know, what is cloud computing and how can it be used to make a business more successful or to make a business more productive? Or what are some of its general implications or utilities in modern day business or something? So they're twofold questions. It's not memorize a definition of this or memorize a definition of that. It's going to be part of what is your opinion of this. And the funny thing is you could define cloud computing in a couple different ways, actually. What is your definition of this concept and how does it apply towards something is how the questions are worded. So they're multiple part questions. So anyway, let's talk about cloud computing, which is one of our last topics for this course. It's a general overused term, kind of like user-friendly. Everything was user-friendly for the longest time. You guys remember something being user-friendly? Now everything is cloud. Oh, it's in the cloud. Oh yeah, it's in the cloud. And the funny thing is that the word cloud is kind of the opposite of what it really is. When I think of a cloud, I think of something that's very foggy, that you can't see through. You know, like on a cloudy day, you can't see the sky normally. It's not very blue. It's kind of black and cloudy. Looks like it's going to rain because you got all this moisture coming down at you soon. So it's actually kind of the opposite of what this really is. So think of the opposite. So a clear sunny day, no clouds. It's clear and transparent. You can actually see planes in the sky, and you can see things, you know. It's like bright and kind of open and useful. That's what a cloud is. It's transparent. It's memory storage. It's services. It's something that you have access to without having to go through a bunch of trouble, without the cloudiness, actually, without any of the dark stuff over you. So it's meant to open things up. So what does that mean? Well, open things up from a network perspective. There's absolutely no difference between the cloud and the network server. You guys have been using cloud since the beginning of the dawn of computing. Back in the 80s, you had cloud technology. You've been using the same technology. We just put a different label on it because we added a different middleware to it. So a cloud is a network server. In fact, I'm waiting. It hasn't happened yet, but this internet is going to turn into a cloud if it hasn't already been labeled that way. It's because that's what the internet is, really. It is a cloud. It's a network cloud where everything is out there. How much security do you have out there? None. How much security do you have in clouds? None. A lot of parallels there. How many computers are on there? A ton. How many are in the cloud? A ton. So people just buy cloud storage, cloud services, substitute the word cloud with network, and you got it. There's nothing new about the clouds. They've been around for centuries. General term used to describe a new class of network-based computing that takes place over the internet, basically a step up from utility computing. Utility computing is an interesting concept. When you wanted something and you didn't want to buy the software, you got the utility. What was the utility? It's hired, rented software. So Salesforce.com is utility computing, but it's also now cloud-based software because now we're going to call it everything cloud. Utility is like, I'm not going to buy the software application. Instead, I'm going to buy licenses, you know, like 5 or 6 different licenses for it. Microsoft 360 is utility computing. So it's nothing brand new. You're not going to buy the software. You're not buying a license. You're renting it for a year. It goes out to the cloud, aka network, authenticates itself, allows you to use it. Your year's up, so is your software. Your utility is gone. You got to buy another year of utility. So think of utility like using software that you don't buy, that you don't own, that you don't install on your computer. So now that we have tablets, who's going to install stuff on your tablet? No one's going to do that. Everything's cloud-based. Everything's utility-based computing. Well, most of your apps, not yet. Give it another year. Give it another year or two. Most of your apps will be Google Cloud apps, or they'll be Apple storage apps. Same concept, cloud, which means it's not stored on your local system, it's stored on the internet. And your local system connects to the internet and uses it just fine. So in the dawn of computing, we had what was called thin clients. Oops, let's not get into there yet because that's a long one. Attendance. Okay, so let me pick up where I left off here. I was talking about, and I do remember, thin clients. So in the original beginning of time, we had thin clients. Then we had thick clients. Now we have thin clients again. So we've gone full circle. We've just changed the words around. So you used to call it a thin client, and a thin client was a keyboard and a terminal screen. Hello, we're back. I don't want to yell over you. Okay. You're done with the attendance, so you could just leave the room if you don't really want to be here. All right, thank you. So, in the beginning we had thin clients, and the thin clients were just keyboards and terminals connected to the network. And then we got fat. We got rid of the network, so we didn't have to worry about connecting to a network. And that's when desktop computing came out, personal computers came out. Because the original thin client was a networked Sun or Unix client, where you'd go into the office and you'd have a terminal window and you'd have a terminal screen, keyboard and everything. And everything you did was on the network. And then we went cheaper. We took the network out of the situation and we got desktop computers or PCs. And then everything was on the PC. It was all inclusive. Hard drives and CD-ROM drives and you had your own screen and you didn't actually have to connect to the internet. And then we did that for several years and then we got fat. So we stored everything locally. Now we're thin again. We're back where we started. Now we have tablets and computers and stuff that don't have any drives on them anymore. They still have hard drives, which is actually kind of funny. But the hard drives are going away. So the hard drives are turning to cloud storage, actually, now. So we're going all the way back. We're seeing the last stages of being kind of, we're in between. We're not thin again, but we're almost thin again. Some of us are thin again because we have tablet computers, and tablets have a processor and they have an internet connection. And if you're not connected to the internet, you don't have anything really to do on your tablet. So that's a thin client, which means, and the thin and the fat refer to how much power and what kind of tools and what kind of stuff is on the clients. And you're the client. The server is the cloud, or the server is the network server, and we have a client server distributed to the internet that everyone's been using for the last decade or so. That's gotten bigger and bigger and bigger to the point now where we have thin clients. We're back to thin. So we've gone full circle. We've just changed the wording around, and the cloud is going to take away all of our local storage. So we don't have, in fact, some computers don't have local storage anymore. Chromebooks, there's no local storage on that sucker. Most people store everything online as well, but you don't have to. You still have local storage in terms of your hard drives and stuff. But that's part of utility-based computing, using the internet and using internet services as part of the computing, or as the computing platform. So going back to the definition, in other words, a collection or group of integrated network hardware, software, and internet infrastructure called a platform. So it uses the internet for communication, transport, provides hardware, software, network services for clients. Everything is out there on the network. So the platforms hide the complexity and the details of the underlying infrastructure, the users, yada yada. Very simple interface, very simple API. A couple companies out there. I think it's Hadoop is one of them that's really, really popular because it's open source. A couple of other companies out there that have products that are mass distribution these days. The cloud is the infrastructure slash platform, but it's all running on the internet, or it's all running on network servers that are primarily internet connected. The internet is nothing more than a bunch of Unix computers all connected together. That's the internet. And so you connect to it by connecting to one of those servers, your ISP, Internet Service Provider. You connect, you authenticate, you get on the network, you're on the internet. So long story short, you're doing that now with cloud software. So the software is on the internet. You're just connecting to the software using the software. What's the software doing for you? Giving you DVD movies if you're Comcast. Giving you file storage if you're the iCloud or the Google Cloud. Giving you software that you can use, apps and things that you can run and have access to. So it's a big old community of network people all storing stuff there. Your Facebook is all cloud-based, Google's all cloud-based, your email's all on the cloud, YouTube's all on a cloud. Everything's stored on a network cloud. So it's about as common day as the computer, if you think about it. So what is cloud computing? In addition to the platform services and the on-demand services, there's always anytime, any place, anywhere access, which is actually kind of interesting because now we're not tied to a single thick client. No more thick client. Our watch, our tablet, our computer, our TV set, all connected to the same computing resources, the same services, makes for better scalability and better usability. So pay for as you use as well. In fact, there's no need to even buy an operating system these days. You just pay for it when you're going to use the computer, you use the computer. And your computer usage is a service for that matter. You're not really buying software. Remember the days you bought software? Actually, you could still do that. You go into Fry's and there's like 1/2 of a shelf left of software. Or if you go online, you can actually buy and download software. That's going away. Within 5 years, there will not be any more software. Instead, everything's on the cloud. Everything is a service. You want to use Office? You sign up for Office. You want to use a program, a draw program, you sign up for it, and you get it, access to it. So pay for a while, you use it, scales up, scales down, in any capacity, any functionality. Hardware and software services are available to the general public, enterprises, corporations, business markets. So we got some vocabulary here. Cloud computing as an umbrella term used to refer to internet-based development and services. Number of characteristics defined in the cloud data. We got remotely hosted applications. Like Salesforce.com is really a CloudForce application these days. It's out there, you just connect to it. You use it. EMS is on an Amazon cloud, by the way. It's a cloud-based application. You connect to it. You go to the internet web browser, you log into your account, you upload your assignments, and hopefully you'll be doing that before the 16th. And you're using a cloud. It's Amazon rented cloud space with an application out there called the EMS. Ambiguous. Services and data are available from anywhere. We don't know exactly. In fact, we're on 3 different cloud servers, which is actually kind of interesting because when we have problems, some students have problems and some students don't. Depends on where your class is stored and which server is having the problem and where you're logged in from. What server did you get connected to? Because it's a group of servers that all work together. It's not just one server, which is kind of interesting. Commodified. Yes, it's like a commodity. The results is similar to traditional utilities like gas and electricity. In fact, it's like internet these days too. You can get cable, internet, telephone all together, like a utility. kind of like gas and water. You buy those utilities, which is actually kind of funny because for the longest time the government's been trying to make it a public utility. It's still privatized, so we're not going to get public network access. Probably not for another 10 years down the road, if we ever get it at all. Because when we get public access, then we'll have publicly monitored internet. The fact that it's privatized makes it open and makes it what it is today. If the government wanted to regulate it, it could, and it will eventually, probably, just like everything else. And in that case, it'll be censored. It'll probably be safer, but less utility to it for the most part. So a lot of people don't want the government involved in there. And if the government is involved in the internet, they're going to privatize. They're going to publicize it, make it a public commodity, and make it like a utility gas kind of thing. But those are private companies as well. So we have a little interesting phenomenon when it comes to private stuff. In terms of the breadth versus the niche market, the applications are really on the niche end of it. The platform and the infrastructure is the widest part. So here's our cloud architecture. We have service value networks on the top. Underneath or in the middle, we have the platform as a service. And then on the bottom, we have the hardware. We have the infrastructure. Then that's what I'm trying to say. The hardware has been there for years. Ever since the beginning of the internet, we've got the hardware. The middleware, the middle section is the new part, the platform as a service. So making the software, or I call it the middleware actually, it's the software that the services can run on top of. That's what gives it a lot of the functionality that we have today. So we have different cloud computing layers. And so we have this application service or server. So we have MS Live as an example of that, Google Apps, Salesforce.com, Quicken Online, Cisco. So SaaS, so application service or software as an application service. Application platform, well, that's where we get our Google App Engine, our utilities, our APIs, our frameworks for building applications and things to, basically reproduce or make, just say, widespread applications from frameworks and tools. Then we have our service platform, SliceHost, Amazon, 3Tera. Basically, it's just going to be essentially, Amazon was the storage platform. It's now a service platform now as well, server platform. And then our storage or service. So we're going from a software down to a hardware perspective in terms of this layering approach. And in terms of looking at this in terms of the application approach versus the infrastructure approach, the application level is the services, the development of those, everything that's above the middleware that we're calling the platform, which is going to be down the bottom of our platform, our storage, or hosting. It's going to be the lower levels. So if you think of the cloud sort of as a hierarchy of levels of different functionality, you've got a good background, hopefully. And, to talk about a cloud is just very generic in terms of its terminology. Now, you can really focus on different vendors like Cisco or Amazon cloud services, and then you can definitely see the differences between the different service providers or the different utilities out there. But in general, they all show these different characteristics. So some characteristics, some basic cloud characteristics. We have the no need to know. So underlying details and infrastructure application details, we don't need to know that stuff. All we know is we have a group of servers that we're using. Who cares what we're getting? Which is what you get like when you basically install something on a group of Amazon servers. You just buy bandwidth. And however many servers that is, who knows? Who knows where your stuff is, really. Flexibility, elasticity allows the system to scale up, scale down, grow. So it's good for small businesses because the small business doesn't need to buy a huge old server, but can have huge old server access. In fact, you can have a small business, 1 or 2 people, and have the same infrastructure as Google if you wanted to, as long as you're willing to pay for it. And you've got the scalability there. Pay as much as you need and as much as you use concept as well. No need to keep the power. It's almost like when you, I wish actually utilities are like this. I wish property tax was like this actually, because in utilities, if you're not home and you leave the lights off, you're not paying for it, which is actually kind of funny because people will leave the lights on and leave everything on and then leave. In the old days, In the old days, people used to do this. And then you're paying for these utilities. And then they got smart now. Well, why don't you just turn the lights off if you leave the room? Hey, novel concept. Or turn this off, or turn the TV off, turn the appliances off. And then the funny thing is, though, is if you own multiple houses or if you travel a lot, you're paying the property tax of living where you're living, whether you're there or not. Which is kind of a bad concept. So I like the pay-as-you-need kind of concept. But you have other things that, like, for example, property tax. Also, talk about your cable bill. It's just like your cell phone bill, actually, if you think about it. You're paying for minutes you're not using if you're paying for a flat fee. And you just have a standard bill you're paying every month. But what if you don't use your phone? Then you have the other companies that come out and say, oh, okay, like Metro PCS or something, that come out and say, hey, okay, if you don't use it, you don't, pay as you go. Prepaid, or, And unfortunately, the stigma of those types of services, it's generally not as flexible, kind of strict, not as good, usually quality of service, as the huge $200 cable bill you're going to get. So it's like, do you want to give your cable company $200 a month, or do you want to stream your videos through Netflix on the internet for $9.95, for $10 a month? Yeah, you're going to have to put up with a few internet issues probably on the streaming part of it, but you're only paying $10 instead of $200 or something. So it's like the same thing with cell phone service, but things like property tax don't work that way, which is kind of ridiculous. But, electricity works, pay as you go. Turn your lights on, you don't have to pay for it, so, which is actually kind of funny. So anyway, so going back, this is the flexibility you get, the pay as you need. You don't need a computer, which is kind of interesting. Why do people travel with computers when you think about it? In fact, hotels got smart a long time ago, and they started putting computer terminals in the lobby. You want to check your email, you just go out to the lobby, or you go to an internet cafe or something, and they have computers there. Just log on, check your email and stuff, which is actually kind of interesting. This is more like computing as a service versus carrying a computer around. Why do you want to own a computer? It's just ridiculous. So. And then you gotta carry everything around with you. That's a lot of baggage. It's like cars. Why do you want to own a car if you live in the city? You get one of those rent-a-car things. Actually, they're pretty hip right now. You get a car when you need it. I can't remember the name of the company, but you just, you email them, you text them, and say, hey, I need a car. The car just shows up. Or you go somewhere, hey, car's down the street. Okay, and here's the key. Actually, some of the companies give you a key. You just carry the key around with you, and the key works in a bunch of cars. And whenever you use the car, you just use the car. You don't need the car. You don't pay for the car. You don't pay for parking on the car, maintenance, all that other stuff associated with the car. Kind of like a rental car, actually. But now we're doing that with our just rental cars with computing services, applications, and companies are doing it. So companies are renting out their accounting and their marketing and all of those other applications instead of buying them. So clouds are transparent to users and applications, as I mentioned before, that transparency, which is the opposite of what the word cloud actually means. So think of the opposite of that. It's transparent. We don't know who's on there. We don't even know where the application is from or where it's being delivered from. Build multiple ways. Branded products, proprietary open source hardware and software just off the shelf. Computing, computers, just anything. It's very generic and transparent. And built on clusters of PCs and servers for off-the-shelf components, plus open source software combined with in-house applications. There's a lot of open source cloud services out there, actually. So when you take a course in cloud computing, hopefully you're learning how to program some of those services or how to create applications to be used in some of those services. So, in terms of software as a service, that's where this SaaS comes from, and they kind of abbreviate it kind of an interesting way. Models application from service providers to customers across the internet, generally used to refer to software rather than consumer software. It's server software. Falls under Web 2.0. Falls under Web 3.0 as well. In fact, Web 3.0, you don't even have the software. It's just the service. You want internet? You got it. You want this? You got it. There's no software involved in any of that. So you remove the install and the running of application on one's own computer. You run it from a centralized location. Alleviates the burden of software maintenance. Not really going to be a reality, however, until the entire world has internet access, and it has good internet access, which is why a lot of companies can't deliver software solely as a service. which is kind of interesting that Microsoft took the leap so quickly. But they made it so that you only have to register it. You can actually use Office without an internet connection. Because what happens to people in the Midwest who don't have an internet connection? They have dial-up service or something. Or you're traveling or you're in a remote area and you don't have the internet. It's going to be hard to use your computer, which is the problem I have with a lot of these tablets out there. I have an iPad, but I have an iPad with 4G service on it. I had an old iPad that just had Wi-Fi on it, but what if I'm not next to a Wi-Fi network? The thing is useless. So I carry it around with 3G or 4G service on it, and I always have a connection. It makes the product more usable. So all of those little Android tablets out there, some of them are just kind of senseless and useless. Because if you're going to be around an area where you have internet access, you're going to have your computer with you. Why are you going to have that thing with you? So, I mean, the concept is, without having to be tied to a building or tied to a house or something like that. So virtualization is another concept that works along this line. So virtual workspaces, abstraction of there being an environment that can be made dynamic and available to advertise to clients using well-known products and protocols, resources, implementing of virtual machines, which is actually kind of interesting. We don't think of the internet now as being attached to an operating system. If you're on a Windows system, you can connect to the internet. If you're on a Mac, you can connect to the internet. A Windows tablet, iPhone tablet. In fact, a lot of our applications are now working universally. And I have to give it to Apple as being the first one to actually create the universal app coming up, where the app works on an iPad or an iPhone or on a Mac computer. It's the same app. They haven't gotten there 100% yet, but it's getting there, which is kind of interesting because Windows sort of did it with Windows 8, but there's only a tablet Windows 8. But there's a desktop Windows 8, so you could run Windows 8 apps on a computer with a keyboard or a tablet computer. And then people decided, well, let's just turn our tablets then, or the Surface or something like that. Let's just turn it into our computer. Great. So you buy a keyboard for it, you buy a mouse for it, and you might as well just buy a computer if that's going to be the case. Actually, it's going to cost you more usually for the tablet with a keyboard. Anyway, long story short, the concept of there being an operating system, now it's a virtual machine. It's whatever you're connecting to, it's all the same program, all the same app. It's a virtual machine. So you have a hardware with some hypervisor on top of it with, let's say, for example, as a virtual machine software. And then you have operating system 1, 2, 3, app 1, 2, 3. We'll take that all away, just put it all in the cloud and connect to it. So I actually connect to the same software that I use on my Mac, I use on my Windows machine, I use somewhere else. I can't do it with stuff I have to install on the Mac, but with services, does it really matter where you check your email from? Do you do it on a tablet, or do you do it on a Windows computer or a Mac computer? So now it's a matter of what operating system do people like versus what functionality they want. Functionality, actually, in my opinion, is greater on a MacBook than it is on a Windows system. Windows are kind of functionality limited because it's all still on the computer itself and not very much Mac-based, but cloud-based. Anyway, that implementation of the virtual machine concept, also providing the infrastructure, the API for the plugins, and then here we have a bunch of virtual machine, VMware as an example. UML actually started out being a virtual abstraction. You can design object-oriented programs in UML. You can design operating systems in UML. UML is pretty universal. Used for Java, C++, Objective-C, anything object-oriented. Performing here purpose and benefits. Let me just finish up a few minutes here because I know you guys are on schedules. Cloud computing enables companies, applications, system infrastructure dependent to be infrastructure-less. No hardware bill, no infrastructure, which is actually kind of cool. So you can pay for cloud infrastructure, pay as you go. So put the data on the platform instead of on your own desktop or your own PC. Now you can actually share the work product of all your employees. So a lot of companies like this because now if I take my notebook home over the weekend and I lose it, I haven't lost anything. Everything is on the cloud. All my Google Docs, everything is out there shareable, collaborative and working environment, and then it's backed up. It's because it's actually being backed up multiple times as well. But long story short, it's more reliable, more accessible than it would be. So if I don't have this computer, I have another computer, no problem. I still have the same document with me. Doesn't really matter. Purpose and benefits in terms of the term cloud is used to describe and reflect the class of internet-centric computing infrastructure. So cloud computing today is a network-based computing over the internet. So you could say that the cloud computing in general is nothing more than what we saw in the 1950s or 1960s with the first Unix box that was ever distributed out to mainstream America. And that we haven't changed at all, and that we've gone full circle, and we're back. We're done with the PC world. Now we're back to Unix platforms. Because you do hopefully at this point realize the internet is 100% or 99.9% Unix based. Although Microsoft has been trying to push out servers for years, it hasn't made an impact. It is still majority Unix servers. Microsoft servers aren't as compatible. They're not as... In fact, Microsoft goes from a Microsoft to a Unix back to a Microsoft to communicate back and forth, so it's slower. So, long story short, we've gone full circle. In terms of cloud sourcing, why is it becoming a big deal? Well, using high-scale, low-cost providers, you can get big services from big companies for very inexpensive. Anytime, any place access via web browsers, rapid scalability, incremental cost, and load sharing. Can't forget the need to focus on local IT as well. Concerns, the biggest concern is performance, reliability, software license agreements. And that's my problem with Microsoft software actually. If it's cloud-based, I haven't done the 360 route yet because I haven't had to, but do I want to pay $99 a year? Every year? Or $49 or whatever it is? You guys using that yet? Some of the tablets have it on there. I've yet to register that or to work with that. They have it for the Mac as well. But I kind of like my older version right now because I own it. I don't have to worry about paying a bill next year when it comes due. Control of the data. That's another problem I have. I like to store things on my local system. I want to make sure that it's my file and not spread out throughout. That's why I don't do very much social media stuff and I don't do any Google Docs stuff, because you're giving it to somebody, the world actually, and it's not, you don't have control over it. When it's on your computer, you have control over it. When you stick it out there and make it available to everybody out there, you don't have any control over it. And then a lot of people go, well, I'm not making it available. I'm citing through my account and I'm pressing this button that says make it private. It's a button on an application. Outside of that application, it's public. So just because the application for which you gave it to the internet is not technically allowing other people to look at it, doesn't mean other people aren't looking at it, or nor that will that application go away. Classic example, I have 3 pictures I put on MySpace years ago. They're golf pictures, they're not bad pictures. Occasionally during a Google search, mind you, I deleted them, and I deleted the account. This is MySpace. It's still around, by the way. But MySpace is like years ago, before Facebook. Some people never even heard of MySpace before. I closed the account, deleted everything off of there, deleted it multiple times, opened the account back up, deleted it again, just to make sure it was deleted. Those 3 pictures are still in circulation. I can do a Google search and I can still find all 3 of those pictures, which is amazing because I thought it would be gone completely at this point. They're not bad pictures, they're golf pictures. Actually, one of them is a really good picture of me swinging a golf club, but they're still out there, which means I have no control over that. So just imagine all those pictures you're uploading to Facebook. They're never going away. You're going to see them years from now. So don't put anything out there you don't want to see a couple more years from now. Luckily, I only had 3 pictures, and they were good pictures. But I still will not put anything out there anymore because of that reason right there alone. And when I signed up for my MySpace account, it was private. And I clicked the button that said make it private, make this private, make that private, only my friends. But the pictures are still out there in a regular Google search. They come up all the time. You may have seen them. One of them is a really good golf shot when the golf was behind my neck. I had a really good shot on that picture. The other one was me walking down a part of the course. Anyway, long story short, don't put any pictures of me out there either. I don't like pictures on the internet. On that note, I think it's time to end this class for today. I still have a little bit of this lecture left, actually. In fact, I still have most of the lecture left. I'm only on slide 16 or 17. I will remember to start next time on this lecture. And next class meeting is our last class meeting, so I would take this opportunity to do all of your assignments and get everything submitted early before the last week of class. Okay, see you next week.